S is a non-empty subset of R bounded above and t equals to minus x as x belongs to S. Then prove that t is bounded below and infimum of t equals to minus supremum of S. First answer. First we show that t is bounded below. Since S is non-empty subset of R and bounded above. Therefore, by supremum property of R, supremum of S exists. That means sup S exists. Because by supremum property, every non-empty subset of R that is bounded above has a least upper bound. That means has supremum. So S is non-empty bounded above subset of R. So S supremum of S exists. Now let capital M equals to supremum of S. Then let Y be an arbitrary element of T. Then obviously minus Y, therefore minus Y belongs to S. Because minus Y, minus of minus Y equals to Y belongs to T. Here X belongs to S implies minus X belongs to T. Now minus Y belongs to minus of minus Y, Y belongs to T. So Y arbitrary element of T, so obviously minus Y belongs to S. But since capital M equals to supremum of S, therefore minus Y less than equals to capital M by definition, and therefore this implies Y greater than equals to minus capital M. Now what is the definition of lower bound? A real number L is said to be a lower bound of a set A if every element of A is greater than or equal to L. That means X belongs to A implies X greater than or equal to L. So here Y is an arbitrary element of T, that is every element of T greater than equals to minus of capital M. Therefore minus of capital M is a lower bound of capital T, lower bound of T. Therefore, what is the definition of bounded below set? A set is said to be bounded below if the set has a lower bound. Now T has a lower bound, therefore T is bounded below. So we prove T is bounded below. Next we have to prove the infimum of T equals to minus of supremum of S. Next we have to show that infimum of T equals to minus of supremum of S. Now let epsilon greater than 0. Since capital M equals to supremum of S, therefore P less than equal to capital M, P is strictly greater than capital M minus epsilon for some P belongs to S. Properties of supremum by now P greater than capital M minus epsilon implies minus P less than minus of M minus epsilon implies minus P less than minus M plus epsilon. Since P belongs to S implies minus P belongs to T. So let minus P equals to Q. Therefore Q belongs to T. Therefore we get from here Q less than minus M plus epsilon. Also minus capital M is a lower bound of t. So every element of t greater than or equals to minus of capital M, that is small q greater than or equal to minus of capital M. So from this and this we get q minus m less than equals to q strictly less than minus m plus epsilon. For some q belongs to t. This shows that by properties of infimum, this shows that minus capital M is the infimum of t, that is infimum of t equals to minus capital M. Therefore, infimum of t equals to minus capital M means supremum of S. That means sup of S. Proved. If you like this video, please share and subscribe.